This video goes with section 14.1 out of the Musser book for mathematics for elementary teachers, and we're talking about congruent triangles. So the first thing we have to make sure of is that we understand what the definition of congruent means. Congruent does not mean equal. You can only say that things are equal if you're actually talking about numbers. So for example, 2 is the same thing as 6/3. Or you could say that the length of one piece is the same as the length of another piece. But when you're actually just looking at a shape, all you can say about the two shapes is that they are congruent. So you can say that sides are congruent, you can say that angles are congruent, you can say that the entire triangles are congruent. And that's what we're going to be proving today. So the first thing that we have to talk about is what makes triangles congruent. Well, you're talking about two angles that would be the same size. You have the rest of the angles being the same size, and you have the rest of the sides being the same size. And the only difference is that they are different spots on the plane. They can be in different areas of the plane. So the question is, how do you prove that two triangles are in fact congruent? Well, first you have to start by looking at what makes a triangle in the first place. So how can you even say that you have one specific triangle that you could make? Because if you know that you can prove a specific triangle and then just prove that the other one has the same exact sides or same exact angles, then you can say that those two triangles are congruent. So you don't have to prove all of the sides. You don't have to prove all three sides of each. You don't have to prove all three angles of each. There are certain combinations that you can prove that will be enough. And that's what this video is going to address. How do you know what's going to be enough? So now we're going to look at one triangle just so we can prove what's going to be enough for us to prove. So the first congruence that we're going to prove is side angle side. Okay? Here I have an arbitrary angle. Okay, this orange piece right here is just some unmeasured angle. Okay? And I have a side and I have another side. So the question is this enough to prove that I'm going to have congruent triangles if I have two that have the same exact measurements? Well, the good news is that there is only one piece that will fit in between. And if there's only one piece that will fit in between, then you know that that is enough to make one single triangle. And yes, you could prove that the two triangles are congruent. So you could prove with side angle side. Keep in mind that when they do say side angle side or SAS, that order is very specific. It's got to be a side with an included angle and another side. So that is one possible proof to decide if two triangles are congruent. The second proof is angle side angle. So if I have two angles, and again, an included side, because it's angle side angle, so it has to be included. If I have two of those, would I be able to make only one triangle in that way, okay, with those measurements? So we're going to take a couple more straws, and we're going to show that you can only make one triangle using those two angles. So if I try to put a side here, and I try to put a side here, they are only going to cross in one way. And so I could easily trim these And I could definitely say, oh yeah, I can make one triangle with that angle and side and angle. And so there's only one way to complete that triangle. And so if that's all you have, you could in fact say that two triangles with that combination would have to be congruent triangles. The last property is, or the second to last property, is side, side, side. So, could you prove it just by having three sides? Well, similarly, if you had these three sides making a triangle, that's it. There's only one way to make this triangle because that's the only way that the sides will connect. So if you have the sides measured, then yes, if you have another triangle with the same exact sides, then you could say that those two triangles are congruent. So the question really becomes, why can't you do angle side side? So how come that one is not a property? That's what we want to figure out. So let's see if we could figure that out. Angle, side, side. Okay? So we're going to say that these are the things that we're being given. Angle, a side, and a side. Here's the issue. I have multiple triangles that I could make with this combination because I don't have enough information that it would only be one triangle. So I could make this triangle, and that would satisfy an angle side side. But I could also make this triangle, and that would also satisfy that particular angle side side because I didn't change this side, if you notice. So this is the same side, and I made this obtuse triangle, and then I could do the same exact thing and make this triangle. So I don't have enough information to say that there's one unique triangle, and so that would make the two triangles congruent. Because one of the triangles could look like this, and the other triangle could look like this. And they would still adhere to the angle side side. So a good way to remember that is don't make an S out of yourself. You cannot prove angle side side.